Imagine a continent splitting in two. It sounds like something out of a science fiction movie, but it's actually happening, right now, in Africa. And the process, driven by immense geological forces, may be occurring much faster than scientists previously predicted. This isn't just a geological curiosity. It has profound implications for the future of the continent and the millions of people who live there. Let's dive into what's happening and why it matters. We're not talking about something that will happen millions of years from now. This is a geological process unfolding today, with visible changes on the landscape, and new evidence suggesting it's accelerating. This video will explain how a continent can break apart, where it's happening in Africa, and why recent findings are causing scientists to reevaluate their timelines. The East African Rift System is creating a new ocean, and the implications are enormous. To understand what's happening, we need to look at the East African Rift System, EARS. This is a series of rift valleys stretching for thousands of kilometers, from the Afar Triple Junction in Djibouti and Eritrea, down through Ethiopia, Kenya, Tanzania, and Mozambique. It's one of the most geologically active regions on Earth, and it's where the African continent is slowly being pulled apart. The EARS is a divergent plate boundary, where the African plate is splitting into two new plates, the Somali plate to the east, and the Nubian plate to the west. This process is driven by the movement of tectonic plates, the massive pieces of the Earth's lithosphere, the crust and uppermost mantle, that are constantly shifting and interacting. In this case, mantle plumes, upwellings of hot material from deep within the Earth, are pushing upwards beneath East Africa, causing the crust to bulge, stretch, and eventually crack. This rifting process isn't smooth or continuous. It happens in fits and starts, with periods of relative quiet followed by bursts of activity. The stretching of the crust creates long, deep valleys, known as rift valleys, which are often characterized by volcanic activity, earthquakes, and the formation of lakes. The Great Rift Valley, a term often used interchangeably with the East African Rift System, is actually a series of interconnected rift valleys, each with its own unique geological features. It has many volcanoes, including the active Ol Doinyo Lengai. This volcano erupts a very rare and unique lava type. The natrocarbonatite lava is much cooler and less viscous than other lavas, allowing it to flow more like water. It is black when erupted and turns white after some time. For a long time, scientists believed that the splitting of the African continent was a very slow process, taking millions of years. The conventional wisdom was that the plates were moving apart at a rate of just a few millimeters per year, comparable to the rate at which your fingernails grow. But recent research, using advanced GPS technology and satellite data, is suggesting that the process may be happening much faster in some areas. In 2018, a dramatic crack, several kilometers long and up to 50 feet deep, suddenly appeared in southwestern Kenya, cutting across roads and damaging homes. This event, while localized, provided a stark visual reminder of the forces at play. While this specific crack wasn't directly on the main rift valley, it's related to the overall tectonic stress in the region. More significantly, studies using GPS measurements have shown that certain parts of the East African Rift System are spreading apart at rates of several centimeters per year, significantly faster than previously thought. This accelerated movement is not uniform along the entire rift system. It's concentrated in specific areas, particularly in the Afar region of Ethiopia, where the crust is thinnest and volcanic activity is most intense. The Afar region is a triple junction, where three tectonic plates, the African, Somali, and Arabian plates, are pulling apart. This region is already below sea level in places, and it's experiencing frequent earthquakes and volcanic eruptions. In 2005, a large volcanic eruption in the Afar region was accompanied by the opening of a 35-mile-long crack in just a few days, a dramatic demonstration of the speed at which the Earth's crust can be deformed. The Afar region of Ethiopia, Djibouti, and Eritrea is arguably the most dramatic example of continental rifting on Earth. This region, also known as the Afar Depression or the Afar Triangle, is a geological triple junction, a place where three tectonic plates, the African, Somali, and Arabian plates, are pulling apart. This is where the East African Rift System meets the Red Sea and the Gulf of Aden, both of which are already young oceans formed by the separation of tectonic plates. The Afar Depression is a low-lying region, much of it below sea level, characterized by intense volcanic activity, frequent earthquakes, and dramatic landscapes. The crust here is extremely thin, in some places only a few kilometers thick, compared to the typical continental crust thickness of 30 to 50 kilometers. This thinning is due to the stretching and pulling apart of the plates, and the upwelling of hot mantle material from below. The 2005 Dabaho Fissure event in Afar provided a remarkable opportunity for scientists to study the rifting process in real time. A large volcanic eruption, accompanied by hundreds of earthquakes, led to the opening of a 35-mile-long, 56 kilometers, and 20-foot wide, 6 m, crack in the Earth's surface in just a few days. This was one of the largest rifting events ever observed, and it provided valuable insights into how continents break apart. Scientists were able to use satellite radar data, INSAR, interferometric synthetic aperture radar, to measure the ground deformation and to model the movement of magma beneath the surface. The implication of all this activity is that the Afar region is, geologically speaking, a new ocean in the making. Over millions of years, the continued rifting will eventually lead to the separation of the Somali Plate from the rest of Africa, and the Afar Depression will be flooded by the Red Sea and the Gulf of Aden, creating a new ocean basin. This is a slow process on a human timescale, but it's a dramatic example of the ongoing, dynamic nature of our planet. The accelerated rifting in East Africa has significant implications for the people who live there. While a new ocean won't appear overnight, the ongoing geological activity poses a number of risks. Earthquakes are a constant threat, and they can damage infrastructure, trigger landslides, and cause loss of life. Volcanic eruptions can release ash and toxic gases, disrupting air travel and posing health hazards. The formation of new fissures and cracks in the ground can damage roads, buildings, and farmland. In the long term, the changing landscape could displace populations, alter water resources, and create new challenges for agriculture and infrastructure development. As the rift valleys widen and deepen, some areas may become uninhabitable, and new lakes and waterways may form. The geological changes could also affect the region's climate, potentially leading to changes in rainfall patterns and temperature. However, the rifting also presents some potential opportunities. Geothermal energy, harnessed from the Earth's internal heat, is a promising source of renewable energy in the region. The volcanic activity creates fertile soils, which can be beneficial for agriculture. And the unique geological features of the Rift Valley attract tourists and scientists from around the world. The events in East Africa are a reminder that plate tectonics is a continuous process. Continents are always moving, shifting, and reshaping the Earth's surface. While we often think of geological time in terms of millions of years, significant changes can happen much faster, especially in geologically active regions. The East African Rift System is a unique natural laboratory for studying the process of continental breakup. By monitoring the ongoing activity, scientists can learn more about how continents split apart, how new oceans are formed, and how these processes affect the Earth's climate, environment, and life. And this is not just relevant for Africa. Other regions show this happening, such as the Baikal Rift Zone in Siberia, the Rio Grande Rift in North America, and the Rhine Rift Valley running along with western Germany and eastern France. So, is Africa really tearing apart faster than expected? The evidence suggests that, yes, in some areas, the rifting process is happening more rapidly than previously thought. This doesn't mean the continent will split in two tomorrow, or even in our lifetimes. But it does mean that the geological forces at play are active and powerful, and that they pose real risks to the people and communities living in the region. It also means we have a unique opportunity to study a fundamental geological process in action, and to learn more about the dynamic nature of our planet. What do you think? Are you surprised by the speed of the rifting process in East Africa? Are you concerned about the potential impacts? What do you think should be done to prepare for the future changes? Share your thoughts, your questions, and your perspectives in the comments below. Let's have a respectful and informed discussion about this fascinating and important topic. And if you enjoyed this exploration of the East African Rift System and the forces that are reshaping our planet, please subscribe to the channel. We'll continue to bring you in-depth looks at the science behind the headlines, the mysteries of the natural world, and the challenges and opportunities facing humanity. Give this video a thumbs up, share it with your friends, and hit that notification bell so you don't miss our next adventure. Until next time, stay curious, stay informed, and remember, the Earth is always changing, and we need to understand those changes to build a safer and more sustainable future.